Hi everyone, welcome to our video on finding concavity and inflection points where we have an exponential function that's involved. Alright, so it is just a scroll, so this is all being saved so far. So these are the steps that we will follow, and it's still, if you see, so this is the actual directions where we will see where it's concave up and concave down. We still want to think of those two people that I drew. Let me go ahead and block this off. Okay, so now let's break this down. Okay, so step one is to find the domain. Okay, which can be helpful with our number line. The domain for this, so the t in the numerator is fine. That's a polynomial, so that means there's no restrictions. And e to the t is also fine. It's never zero. It has no restrictions. So t and e to the t both have in negative infinity to positive infinity interval for their domains. And because e to the t is never zero, so this is always true, e to the t is never zero, that means this is just going to be the domain. Okay, so if zero could occur down below, then we have an issue, but that exponential function never does become zero, so we're in the clear. Okay, so that means our domain is just, let's go ahead and box it, make it official right there. Okay, then the next thing, now they used y in this problem. I'm going to change it to f of t. I prefer that in these scenarios. And with this way that it's written, I would need to use the quotient rule. However, I'm going to use a negative exponent rule so that I can rewrite this and use the product rule. So I think that might be easier. So let's rewrite it as f of t equals t e to the negative t. Okay, so I'm using the negative exponent rule on the denominator. And then now that it's written like this, now I could do the product rule instead. So again, you could have left it like that and done the quotient rule. I'm going to use the product rule because I think it's a little easier. All right, so then I do have my product rule, which I'm going to just state as we do it. So this is u and this is v, and we know it's the derivative of u, so it's 1, times just the v, e to the negative t, plus just the u, which is t, times the derivative of v. Now the derivative of v is itself e to the negative t, times the derivative of the power, which is negative 1. Okay, so the derivative of negative t would be negative 1. Okay, and then now we can start to simplify. So f prime of t, I would have e to the negative t. And then over here, the plus and the negative 1 would make that a minus. So it's minus t e to the negative t. And then because I have the e to the negative t in common in both terms, I'm going to factor. So we have f prime of t is equal to e to the negative t, and then factoring that out would leave us with a 1 minus t. And then again, you could check with multiplication. Okay, so this is our first derivative. This is good for if they ask for increasing or decreasing. So they did not, so let's move on. Okay, so let's keep finding it. So now I want to find the second derivative. Well, this is still a product. This is my u and this is my v. All right, there and there. And so again, in words, I'm just going to state it. So the derivative of u, so the derivative of e to the negative t is itself e to the negative t times the derivative of its power. So the derivative of negative t is negative 1. And then times just v, 1 minus t, plus just the u, e to the negative t, times the derivative of v, which looks like it'd be, so the derivative of 1 is 0, the derivative of negative t would be negative 1. And then now we can go through our steps to simplify. Okay, so we've got this here. I'm going to put it in blue. This we could distribute into here if we wanted to. Actually, instead, let's do that. Let's go ahead and no, let's not do that. Okay, so I'm changing my mind. So you could do that in the blue. Let me erase. And instead, I'm going to highlight to show what I could just factor out. Okay, so this is what it looks like. Now, instead of distributing, I'm going to do kind of what I did in our f prime step, where I see, hey, this is in common in both, so is -1. So that means I could take both of those out. So I have e to the -t and -1 getting factored out, which means I'm left with, this is what I'm left with if I took these two out of this big first term. So I have a 1 minus t left over, and then I have plus, all of this got taken out of the second term, so that means I'd be left with a 1. And then that way I can simplify and write it as f double prime of t is equal to, now the -1 we'd probably put first, so -1, and then the e to the -t, and then 1 plus 1 is 2, so 2 minus t like that. All right, and so that is our second derivative. I'm going to keep the -t power. You could change it if you want into a positive t if you move it down to the denominator, but I'm going to leave it just like this. Okay, so there's our clouded derivative, second derivative, and then now I need to find its critical numbers, which is to set the whole thing equal to 0. And then we'll set each of those factors individually to 0. Well, the first factor is just a constant, so that doesn't make sense, so we would just move on. And then e to the -t being set equal to 0, and then 2 minus t also set equal to 0. So I'm just setting all these three factors equal to 0. The first one I just crossed out because it didn't make sense. Well, this second one, we just talked about it in our domain. E of t is never 0. So same deal with e to the -t. This will never be 0. So this one has no solution. Okay, you could also, if you really wanted to try, you could try to take the ln of both sides. ln of 0 is undefined. So that means, again, no solutions. All right, whereas this one, it looks like it's just t is 2. So if we add the 2, or subtract 2 and divide, I'm going to save those steps and just get our 1t value right there. Okay, so it looks like we only have one value here that's important to us, the one critical number. And then now we go to our number line. So step 4, number line. And we have 2. That's it. T equals 2. All right, and then now, so this is going to be my t value. And then I changed it to f instead of y. So I'm going to write this, though, as my f double prime. And then here's my f. And then because it's a concavity type problem, I know I have these two people, let's put them right here, to help me out. Okay, and those are the signs of our second derivative, and then this is the concavity of f. All right, and so now I want to just plug values in that are bigger than 2 and less than 2 into our second derivative. So let's do f double prime of 10. So that's bigger than 2. And if I plug it in, well, that's back to this guy that I'm starring. And I would have -1 times e to the -10 times 2 minus 10 would be -8. So I just did a little bit of simplifying. So I'm changing those t's into 10s, and I did some simplifying as I went. Well, -1 is negative. E to the -10 is positive because, again, it never crosses 0. It's always bigger than 0. Or if you think, hey, flip it because it's a negative exponent, flip it down and make it positive. E to the 10 is still positive. And what if you have it in a denominator? Well, it's still positive. So it is positive. And then -8 is negative. So 2 negatives multiplied is positive times a positive is positive. So that's doing it without a calculator. You could just plug this whole thing in and verify it will be a positive number. Okay, and then now I want to choose something that's less than 2. Well, I think 0 is a good choice. And if we plug that into our function, we would have still -1 right there. We would have e to the 0, and then we'd have 2 minus 0 would be 2. Well, -1 is negative, still -1. E to the 0 is 1 times 2, so this all becomes, this is something we could do without a calculator. It is just -2. But the sign is all I care about, little negative there. Okay, and then that tells us how f is going to work. So where f double prime is negative, so f double prime is negative, e to the 0 is negative, so 2 minus 2 would be 2. Well, -1 is negative, still -1. E to the 0 is 1 times 2, so this all becomes, this is something we could do without a calculator. It is just -2. But the sign is all I care about, little negative there. Okay, and then that tells us how f is going to work. So where f double prime is negative, So that's our person right here. Where f double prime is negative, we have that frown shape, we have concave down. And where f double prime is positive, we have a smile shape or a cup, like concave up, looks like a cup. So this is concave up. Okay, and then let's go ahead and mark it now. So it changed concavity and went from concave down to concave up at 2. So that means we have an inflection point at x equals 2. Okay, so it changed concavity, so that means we have an inflection point. All right, well, this was part of step 5, and then to finalize step 5, I'm just going to state what these are as intervals. So it's concave down from negative infinity to 2, and then it's concave up from 2 to infinity. So there's that portion. Let's go ahead and box it up. And then we need our inflection point. Let's go ahead and put it right here as an answer just to keep them all with each other. But our inflection point is to plug in our x value, or I guess t value in this problem, into the original function. So what I need to do is find f of 2. So now I'm back to the very beginning. Well, I used f of t as our variable instead of y, but it's still this same function. So we'll plug it into the t. So now I'm just plugging into my t's right there, into our original f of t. And so I have 2 in the numerator, and then e squared in the denominator. And then this could be fine. I'm going to write it like that as an exact value. So the x value was 2, and then it's 2 over e squared as a y value. Now, if they said decimals are okay, I'm going to put this as 2, comma, and then we'll fill that in. But to do that, I'm going to use my Desmos and see what it looks like. Okay, so we have our, let me exit that, and then let's get this function graphed. Okay, so it's remember, it likes x over, t might be okay. Nope, I don't think so. X, it wants divided by e to the x. Okay, so that's what this looks like, and then at 2 is where it's important. So I need to kind of zoom in there. Notice if I zoom out, not much is going on with this graph, really, anyway. Okay, but it does look like it's concave down, and then maybe something happens. It looks like it just is all horizontal anyway. Okay, so but we have it concave down and then concave up soon. All right, so let's see what happens here. All right, so my inflection point was 2, comma, so let me put it right here, parentheses 2, comma, and then it was 2 over e squared. So 2 divided by e squared, like that, parentheses. Okay, and then to match with our number line, let's go ahead and scroll so I can see both. So there's our number line, and it is definitely concave down, and it is looking like it's concave down until it hits 2. So that does look like a frown. And then afterwards, it's very difficult to see, but apparently it is kind of curving so that it is concave upward afterwards, after this 2. So the graph doesn't really show it too well. Try to zoom in really close to maybe see it a little better. So concave down, and then now it's concave up because it looks like it's headed toward the axis, but it just stays concave. So maybe if blocking it off, it looks a little concave up. I'm going to keep zooming in. So concave down, and then this is making this part of the smile. Okay, so very, very, very tough to see, but it is occurring. It's a very small amount that's occurring. Okay, and one reason that it is concave up is because, well, look how it's above the x-axis. It's got a little bit of a gap, and then afterwards it looks like it's gotta be headed toward the x-axis, but it looks like it's staying above. So if it were to stay concave down, it would go down further. It would keep going downward. It wouldn't level out like this. So that it does have to be concave up there. Okay, but again, it's very tough to see. Okay, but let me click on that point. So 2, comma 0.271 would be the decimal portion of it. Okay, so if decimals were allowed, you wouldn't have to keep it in terms of E. Let's go ahead and just write it, the 0.271 right here. Okay, so that is the inflection point. Okay, so that's that. So there's our graph, or we use the calculator to check it. It's very difficult to see that it's concave up, though. So sometimes it's there, but it's hard to see with the eye. And this process let us know that we did do it, though. Okay, so that's that. So that's using our test of concavity to find our different intervals of concavity and inflection points when they existed. Okay, so if you have questions, please let me know. Otherwise, thanks for watching, and I'll see you next time.